All right, we're gonna continue our identity section here with some trigonomic addition formulas. So sine AB and cos AB. Okay, so the first thing that we want to get out of the way here is, does cos of 30 degrees plus 60 degrees equal cos 30 plus cos 60? So I guess they're asking, is there some sort of distributive property that's happening there? And the answer is no. Inside this parentheses, this turns out to be cos of 90 degrees, okay, and cos of 90, okay, is going to be cos x, so I'm going to go up to 90 degrees here, so my x, this is going to equal 0, right? Okay, but on this side, cos of 30, we know is root 3 over 2, and cos of 60 is 1/2, and it's quite obvious that these two things don't add up. So when we find ourselves in that situation where we have cos, a trig function of cos or sine with a couple of different angles that are added up in here, we go to our sum and difference formulas to get our right values. Okay, and I'm going to leave it up to you guys to try and figure out the little tricks to memorize these. But a couple of things that you might want to notice is that with the two sine formulas, okay, it starts always sine cos cos sine, sine cos cos sine, and when I see my sine here, it's the same as here. When I add with the sine formula, and when I subtract, I subtract. Okay, the cos formulas. Okay, for both of them, they start cos cos, sine sine, cos cos, sine sine, and here the actual sign is different between the two equalities. Okay, so let's put a couple of these to work here and see. We'll just do a couple of examples to see what's going on. So here I see we're just trying to simplify this as much as we can. So I see cos 3x times cos 2x plus sine 3x to sine 2x. And I go up here and I try and figure out, well, which one does this one look like? And here it looks like I've got cos cos, so it must be a cos formula. And I've got the plus sign there, so it looks like I can take all of this and rewrite it as cos of 3x minus 2x. Okay, so that kind of neatens it up for us a little bit. And here, because these are like terms in here, I can rewrite this as cos 3x minus 2x gives me just x. Okay, and so that's a little simplification then, right? Let's go down and try this next one here. So here it looks like I've got sine cos, cos sine, so I know I'm going to look for one of my sine formulas. Okay, and it's got a minus sign in between, so there we are. So I'm going to go sine of 105 minus 15. Okay, and I know that that equals sine of, looks like 90. And I can go ahead and reduce that just a little bit more because I know that at 90 degrees, sine means height, so that all equals 1. Okay. Um, one of the nice uses of this formula, and we're just going to add an example here. Let's try something like, we'll call this 3b. Okay, and that one's 3a. Let's say that I have sine of 75, and I want to find the value of that. All right, so what I can do here is I don't really, I don't know special triangles that deal with sine of 75, but what I could do is I could break that up into a sum of two special triangles. So I know that this is the same as sine of 45 plus 30. So I've got 75 in here, 75 in there, and now I can deal with one of my double angle formulas. So I know that this is going to equal sine of 45 plus, or sorry, cos 30 plus cos 45 sine 30. Okay, and now I go in and I find all my values. So sine 45 is root 2 over 2. Cos 30 gives me root 3 over 2. Plus cos 45 is root 2 over 2. And our sine of 30 is 1/2. Okay, so all of that is going to equal, it looks like I've got root of 3 times root of 2 is going to be root of 6 over 4 plus root of 2 over 4, which is equal to root of 6 plus root of 2 all over 4. Okay, so just a little application of how we can use these double angle formulas. Right, so let's move on to another application here. Let's see how we should do this. I think I'm going to leave 4 as an exercise for you, and I'm going to do the harder one. I think it's the harder one anyway. So I'm going to do 5 for you, and then you can go back up and look at 5 and try and take a crack at number 4 on your own. Number 4 is a little longer because you've got to do two things here. You've got to find sine of the reference angle minus the angle, and here you've got to find cos of the reference angle minus the angle. So it's kind of like two questions in one. But I think 5 is a little tougher, so let's give that one a shot. Okay, so it's just like a little puzzle that we're trying to find here. So let's go ahead and find the formula first. I'm trying to find sine of pi over 3 plus x when sine x is equal to minus 2 over 3, and it's in this part of our grid. Okay, so let's write out the formula first here. So this double angle formula gives us sine of pi over 3 cos x plus cos of pi over 3 sine x. Okay, so we want to be able to find out a couple of things. So let's go ahead and draw a picture here. So if sine x is minus 2 over 3, it's negative, and it's in between pi over 2 and 3 pi over 2, that means I'm in here someplace. But we know that sine is positive here, so my triangle is going to have to be in this quadrant, right? Okay, so we'll draw that in there. And sine is opposite over hypotenuse, so it must be that this side here is negative 2, and our hypotenuse is 3. So I guess that means that our last side here is going to be 9 minus 4. This is going to be square root of 5 up here, right? Okay, so I use the Pythagorean theorem to find that last side. Okay, so what that triangle allows us to do is it allows us to find any value, any trig value for x, for the angle x. So when I go and look here, the sine of pi over 3, okay, so let's draw that in. So pi over 3 is here, right? And the sine of that pi over 3 is going to be root 3 over 2. And cos at this angle, cos is adjacent over hypotenuse, so I'm going to multiply root of 5 over 3. My adjacent, sorry, it should be minus root of 5 over 3. Okay, because we're going in a negative direction here, so this must be negative root 5. So negative root 5 over 3, and then plus cos of pi over 3 is going to be 1/2. And sine x is going to be opposite of our hypotenuse, must be times minus 2 over 3. So what do we got when we add all the, or when we put all this together here? So I'm going to get, looks like a negative square root of 15 over 6 plus negative 2 over 6. So I guess I can rewrite that as negative root 15 minus 2 all over 6. So let's take a look at what we've got here so far. Okay, so we've used our addition formulas to be able to solve for a value of an angle that is in a special triangle by using those special angles adding up to those special angles and then going and calculating the value. We've, under a condition, okay, we found a value under a condition of knowing what the sine of x is and in a certain area of our grid. And then finally what we want to do is we want to start looking at how to verify a couple of identities here with our addition formulas. So what we want to do is we want to start with the side that has our addition formula in it and try and kind of work that into see if we can get it into what the other side is. So here let's go ahead and do that. So I've got cos of pi cos x, and this one's plus here, so that means I'm going to go minus sine pi sine x, and I'm going to see if I can make that equal minus cos x. So I've just applied my addition formula to this side, and now we're going to see what we get. So cos of pi, okay, so let's draw our thing. So pi is here, okay, so the cos, the x value of that is minus 1, and cos x we're just going to leave as the same, and now minus sine pi here is the height at that value at pi, and so the height of that point is 0 times sine x. But because 0 times sine x here, that must equal 0. Negative 1 times cos is just negative cos x. And then we could put minus 0 here, because 0 times any number is going to be 0, is equal to minus cos x. And looks like I've done the identity here. Minus cos x is equal to minus cos x. Okay, so the trick to these is to just keep moving. Okay, even when it doesn't look like we're going to get anywhere, maybe at this stage here, it's kind of important that you say, well, I know the value for cos pi, so I just keep moving, and then the 0 pops up, and that kind of takes care of half of my all of my problems here. So don't quit on these. Always write out what you can see and what you can, and usually it leads you in the right direction. Okay, so let's try another one here. I see that my addition formula is here, so I'm going to go out and write that one out. So cos x cos y plus sine x sine y. So that's all in brackets. Times, now we just write out what we had here. Cosecant x times secant y is equal to cotangent x plus tan y. Okay, so let's go ahead and see what we can do here. If I change this into sine and cos, okay, I'm going to be left with cosecant is the same as we know 1 over sine x, and secant y is going to be the same as 1 over cos x. Okay, so I can cancel those two out. So when I go to multiply here, I can rewrite this as cos x cos y over sine x cos, sorry, that should be cos y, sine x cos y, plus, here I've got sine x sine y all over sine x cos y. Okay, and we want that to equal cotangent x plus tangent y. Okay, so looky here. Okay, I can cancel out my cos y's, leaving me with just cos x over sine x, which we know is cotangent x. And over here, I can get rid of my two sine x's. Sine x over sine x is 1. And I'm left with sine y over cos y, which equals plus tan y. And we've kind of worked our way through that identity. Okay, so again, you just want to make sure that you do what you know, and keep moving forward with it, and not get frustrated with maybe seeing something that looks a little strange. As long as you keep going forward, everything's going to be hunky-dory. Okay, so give those a try. Ciao.